Let's take a moment to understand the ADO.NET object model. Most of the ADO.NET object model is stored under system.data. We'll use the object browser in a moment to explore that namespace. The namespace is quite big, so the best way to understand it is just to focus on some of the core objects. We've broken these out into two categories, one for data providers and the second for data storage. The data providers have a distinct relationship with your data source, whether it's a database, a service, or an object, whereas the data storage represents a disconnected storage mechanism to store your metadata and schema as well as your data. Let's explore these. Underneath the data providers, we have a connection object. For those of you that are familiar with classic ADO, this connection object is not much different. The main property is a connection string which provides information regarding the connection to the particular data source. As you just saw, we created a connection string to connect to our inventory database. Unlike classic ADO, the command object in ADO.NET can be configured to work independently depending on what type of connection it's retrieving. So for example, if the command is executing a retrieve, perhaps you'd want to return a result set. However, if it's a delete, you don't need to return a result set and may choose to execute the command as non-query, meaning only make one trip to the server, not a round trip. This way you can program ADO.NET applications much more efficiently. In classic ADO, you had to reuse the command object over and over again and really couldn't get the benefits that you do with ADO.NET by not only configuring what the command returns, but you can also add logic around an add, an update, and a retrieve that varies depending on what type of command you're executing. The table adapter allows you to connect tables to your connection. It serves as the ambassador, understanding how to leverage a connection to the database and then feeding that information into the data storage side of the house, such as the dataset or data table. The data reader provides serialized connectivity to your database. You could think of this as a data storage mechanism, however, because it needs a persistent connection to the database, it's not fully detached like a dataset would be. A data reader takes a fire hose approach, where the data is transmitted from the database live and non-serialized. On the other side of the house, the dataset and data table are completely disconnected. There's only one persistence format to store the metadata for a dataset or a data table, and that would be using an XML schema file or an XSD file. When we just created our dataset, an XSD file was automatically created for us, storing the schema for a dataset. This would include the data types for the columns as well as the names of the columns itself. Inside of a data set, there could be one or many data tables. Data tables are analogous to record sets in classic ADO, where you have rows and columns inside of a table-like structure that can be grouped together into one or many objects inside of a data set. Let's apply this knowledge to our project in Visual Studio.